Good afternoon, and welcome to DevNetwork's Developer Week webinar series. I'm Patrick Gallagher, and I'd like to welcome all of you to this week's featured webinar presented by Lightstep. Lightstep is a regular sponsor of Developer Week and delivers unified observability with visibility across multi-layered architectures, enabling teams to detect and resolve regressions quickly, regardless of the system scale or complexity. Before we get started with speaker introductions, I'd like to remind all of our attendees that live chat, and as you see, there's already a question pinned to the top. Let us know where you're calling in from, as well as Q&A is available during the session. And you can raise your hand in the chat or ask questions in the Q&A section of the webinar viewer. You can do that to the right of your webinar viewer. We will address your questions at the end of the presentation. Also, this webinar will be recorded and made available within 24 to 48 hours for additional viewing or reviewing. And you can also forward it on to your coworkers if they want to check it out. So, joining us today as your presenter from Lightstep is Parker Edwards. Parker currently manages the Global Solutions Engineering team at Lightstep. He developed an affinity for understanding software performance at New Relic before leaving to start a solutions engineering practice at Lyft Enterprise, where he became a user of Lightstep's observability tools. So, without further delay, please give your undivided attention to Parker.
Awesome. Patrick, thank you. Super excited to be here. In advance, I'll apologize. I saw some reports of choppy video, but hopefully the audio is coming through just fine. I live in a pretty dense apartment complex, and I think a lot of folks are doing video chats right about now. So we'll get through it, but hopefully y'all can hear me. As Patrick also mentioned, there's a question in the public chat right now. Personally, I think having attended a lot of conferences and webinars and meetups, that Kubernetes is as much about the community as it is the technology. So feel free to reach out, put your, where you're calling in from, where you're watching in the chat, and feel free to come find me afterwards. I'm in a lot of the public kind of Hangouts groups on things like Slack, and you can always shoot me an email. And to that end, here are some ways to get in contact with me if you have any questions, you ever want to talk about Kubernetes. But before we go on too much, I also wanted to just give a brief thank you to the folks at DevNetwork, and specifically Patrick and Emily, for having us and for helping us prepare for our webinar today. And with that, I think we'll jump in. So we're here to talk about Kubernetes. And I think the best way to start this out, just to kind of see where we're all at, is with a poll. So we're wondering, of the folks who are here, how many of you are using Kubernetes today in production or have plans to on the immediate horizon? And if you are neither of those things and you're just here to learn, that's also really cool. So just feel free to answer. And I'm going to put my own yes in. Awesome. We're still getting some results, but to share them with you all, it looks like about 15% do not currently use Kubernetes or have plans to on the immediate horizon, but over 63% do use Kubernetes. And there are another about 30% that have plans to adopt within the next 6 months. So I'm excited for y'all. It's quite the journey for those of you who are about to adopt Kubernetes. And this is a great time, again, to just reinforce that as you start along that journey, there will probably be a lot of questions that you have, maybe some problems you run into, but very rarely have we seen those be problems that no one has faced before. So really lean into that community, find some folks on the internet around you, in a couple of months, hopefully when we're able to meet up again, and you talk to folks about your issues, your findings, your wins, your losses. The community around Kubernetes is one of the most exciting that I've had the privilege of being a part of. So a lot of you might know, but I think it's important to start, when we're thinking about the hidden costs of Kubernetes, it's important to start, with why. How did we adopt Kubernetes, and what are the value props that it delivers to us? I started my career on traditional bare metal, and I remember the introduction of vSphere and ESX being just revolutionary. And now, as the trend of abstracting away hardware and infrastructure from developers has reached the point of Kubernetes, there is just this whole new level of convenience, but also tied in with that is best practices and difficulties. Statelessness, ephemeral containers are a different mindset to develop around. And so when we're thinking about the value of Kubernetes, the scaling, the network management, the lifecycle management, and the way that it can make a lot of that easier, there's also the question, what are the things to look out from? And release over release, I always find myself asking, well, now what is it that Kubernetes can't do? And luckily, we've got a slide for that. So the things that Kubernetes doesn't do, for one, it doesn't make things just magically work. If anything, I would say that you have kind of two audiences. For developers, if you follow best practices, it can make your lives much easier. You have the ability to kind of reduce the need to worry about per container resilience. And it just changes the way that you think about self-managing your applications and responding to incidents. And when you have an incident and Kubernetes does its thing and kills some pods, helps you recover, does the self-healing that they talk about, it can seem like magic. Now for the ops teams, the infrastructure teams, the platform teams managing it, the magic is not as present, but that's a whole other webinar. And we're here to talk today about observability and kind of solving for the hidden costs of that within the context of Kubernetes. And to that end, when you're trying to understand the changes in performance, Kubernetes doesn't do a lot to help you there. And we say deployments, but I also think that really, deployments spark change, and change is the catalyst for regression in a software environment. And so when we think about deployments, it's kind of a both specific term for the act of deploying new software, but also you can think any changes in performance resulting from any number of catalysts are not easier to understand in a Kubernetes world. And we'll talk about that more in a moment. We'll also not help you aggregate telemetry. Well, the applications on top of Kubernetes can certainly help you emit valuable telemetry data. Kubernetes in itself is not particularly beneficial when it comes to aggregating, displaying, or otherwise making use of telemetry data. Anyone who has tried to auto-scale Kubernetes on custom metrics, especially in some of the earlier versions of Kubernetes, knows what I'm talking about. And then finally, even if we had all of that data, if we had the right data, Kubernetes itself does not help us answer unknown unknowns. And we're going to talk about that here more in just a moment as well. Before I move on to my next slide, I do want to just call out as well, there is a Q&A. We'll have a Q&A session at the end. If you have any questions, comments, feel free to leave them there. And we'll have a section at the end to go through those. So what does this low-res image mean? What does Kubernetes not do? And we talked on that last slide about the delta between kind of the data that you might need and the data that Kubernetes makes available for you, and the need to take that data and make it actionable. Especially when you have change events like deployments, you end up in this cycle of controlling something, pushing something, changing something, and then observing that change. And that can increase, especially in a Kubernetes environment that is inherently more distributed, more ephemeral, a lot of stress. This is how we think about stress, responsibility without control. And if you look at this triangle, you can imagine if you are a service owner or you own a particular part of your stack, you could imagine yourself as a circle within this triangle. And when you push a deployment, you have your own scope of the world, what you can control. But as you see, there's this interlocking web of dependencies and ways that things can interact with each other in this system. And not only are you responsible for what's downstream from you, if you make interactions to a service downstream, especially if that's a shared resource, the way that you interact with that resource has the ability to impact more than just your team. So you're responsible for that. The same way with upstream services as well. How do you respond to the folks that are relying on you in order for their services to stay up and active? And that delta between what you can control and what you're responsible for can introduce a lot of stress, especially in this software environment. So all of that leads to this concept of hidden costs. And we're going to break this down. There's a couple of different hidden costs that we want to talk about. But you'll probably be either nodding your head if you're using Kubernetes, maybe have some insights to share again with your community, or if you're on your path to Kubernetes thinking, what have I gotten myself into? But it's not as burdensome as you might think, and that's what we're here to discuss. So the first hidden cost is monitoring costs. This is a tweet. We've anonymized the provider, the tool that's being discussed here, but this is probably a pretty common sentiment amongst this audience, right? The overarching, I'm not going to read the whole thing. I think it's a good read though, and you can take a look. The overarching theme is that Kubernetes, in the way that it handles ephemerality, in the way that it handles self-healing, and just the kind of natural overlay of Kubernetes with microservices environments, means that you have a ton more complexity. You have more permutations, you have more tags. If you're trying to answer the same questions, and a lot of those are, is my application available? Are my users having a good experience? What changed in my system? And are we on a path to regression? All of those questions now in this new world of Kubernetes take more data to answer. You have per container, per pod metrics. You have log information. You have a ton of data that you're going to need in order to answer what is the performance of my cluster. And if you're building it yourself, we'll get to that in a moment. But traditionally, you look at things like attribution, tagging as the kind of core attribute alongside volume, which also increases in a Kubernetes environment, and hosts, which is really hard to calculate. All of that means that not only is the cost of monitoring generally hard to quantify and especially estimate, but that the value that you're getting from a lot of those tools is not aligned with your requirements in this new world. The other side is service dependencies. So with service dependencies, this kind of goes back to the stress slide that we looked at earlier. There's a kind of flat circle aspect to technology. I'm not sure if anyone here watches 30 Rock. This is a bit off topic, but there's a quote from a character there that I love. Technology is cyclical. Pagers will come back. And in that same vein, we have a lot of high-profile folks in the observability, monitoring, and tech infrastructure space advocating for the simplicity of monoliths again. And there's certainly value to that, but there's also a lot of values to microservices. And we believe that you can have the value of both without having to introduce more new complexity that you have to deal with in a more reactive way. The big thing here with monoliths is trying to get rid of the service dependency issue. Again, going back to this slide specifically, it would be a lot easier, a lot less stressful if you had less circles on the page. But we don't want to lose the benefits that are inherent to microservices. The last factor here is the bus factor. If somebody on your team gets hit or decides to board a bus out of town, and they are the experts in Kubernetes, what do? How do you then ensure that the rest of the folks around them, the rest of the folks on your team are empowered and trained to be able to make sense of all of the data, all of the infrastructure constraints and the best practices that will allow you to be an efficient organization running on Kubernetes? So that all leads us to this concept of observability. Now, observability is a newer term to the industry, and we're going to break down what that means. But I would imagine if a lot of you have been in the Kubernetes ecosystem or been poking around the ecosystem, you've heard this term. And while it doesn't solve everything, it is a new way of thinking. We think about it from a more philosophical perspective. So observability in general is the process and practice of understanding your system. And the understanding there is the bit that I really want to underline. Because traditionally, when we think about performance, when we think about availability, uptime, resilience, and systems, we don't necessarily think about it in terms of understanding. We think about it more in terms of displaying and ingesting that data. But because the architectures underlying our application stack have gotten more complex, we have more permutations, we have more dependencies, you can't just ingest the data and you can't just ingest the insights. It's required in order for you to be efficient, continue to increase your dev velocity and increase your system's resiliency, for you to actually understand your system. And on the other side of that same coin, as the system grows, it becomes harder and harder to understand. But that's still, maybe a little abstract, right? So the more concise term is observability is the ability to navigate from effect to cause. So in doing that, you obviously want to make sure that you have the right tools and practices in place. But even here, the ability to navigate from effect to cause, you might be thinking, well, I mean, that's just monitoring, right? And that's a great question. So what's the difference? Monitoring as a discipline requires you to define normal and freeze it. And that is just inherently incompatible with the concept of Kubernetes and microservices. Because there's too many unknowns, there's too many permutations, and there's too much cardinality in order for you to create static assets, static images, static queries in your Elk stack or in your log tool that give you the insights that you might need, because no two regressions are the same. Even if it's just the footprint that shifts, if you're focused or if you're relying on static observability, static dashboarding, it's not going to provide you the same amount of value regression over regression. And so we want to shift the way that we think about our systems from one of ingesting insights to one of asking questions. So from that perspective, how does observability help? It's not just adding a new tool or a dashboard. It is a cultural and process change event within an organization. Now, certainly the tools help, the dashboards help. Having the right context and the right tooling to be able to ask those questions is really important. But observability is more about learning to ask those questions, form your hypotheses and test those hypotheses on the fly, and work through your root cause analysis in the same agile fashion that you're probably developing the software that you're trying to root cause or observe into. The big takeaway here before we move into kind of our next section is that the permutations and the complexity and the ephemerality of Kubernetes means that you can't diagnose, you can't troubleshoot your problems in the same way. It's not going to be as much about real-time debugging necessarily if you're following Kubernetes best practices and letting your pods and containers get killed and restarted. Allowing the self-healing to happen means that you might lose access to that data or those insights. So you need the ability to collect the right data, collect more data easily, and ask questions of that data set, either historically or in real time. So all that, what are the hidden costs? How do we quantify that? And when we think about the cost of monitoring a system, if you've ever gone through procurement for open source software, or the hardware to run open source software, or a monitoring provider, you've probably run into this. So we think about it in two ways. Obviously, capital expenditures, capital costs required for the collecting and the storage of that telemetry. That can be infrastructure that you run yourself. In some instances, that can be software that you buy off the shelf. Software that you buy off the shelf. That's much easier to quantify than the operational costs, because these are less tangible. They're harder to measure, but they're also generally the more expensive part of the equation. So we're going to walk through this, but you can think of OpEx costs here as the time required for engineering to investigate that data and make sense of it and get your business back into a healthy state. So we'll go through this very briefly. The webinar, of course, is being recorded if you want to capture this or come back to it, or as always, if you want to reach out, I'm happy to spitball and work through some estimates with y'all. But let's assume just for a brief moment that we're going the OSS route. We're going to embrace Elk, or we're going to embrace maybe a tracing solution like Jaeger or Zipkin, and we're going to run that on top of maybe like Elasticsearch or Cassandra. In that instance, we have trying to stay around 50 gigabytes of log data a day, 14 days of retention, high availability. You want those queries to be fast. The costs here, as you can see, is about $716 in your cloud spend alone. Now that's not bad. That's about, after setup and maintenance, about $3,300, $3,400 US dollars a month. And that's less than half the salary of a single developer in a lot of regions, especially the ones that I've seen on the right as everybody's been chiming in with their location. Now, the more difficult side is the operations cost. So $716, $3,400 per month. But what about the operational side, right? This is harder to quantify. And while we've put some metrics up here, we've put some factors that we think are really useful, your mileage may vary. You and your organization will have separate factors, separate metrics that you're going to look at in order to quantify the operational costs of observing your Kubernetes environment. Some of the ones that we think are pretty static, how much do you pay your engineers? How much does an engineer cost? How much time do they work? And how many disruptions are they investigating in a year? And especially that last one, as somebody who's been in the APM and observability space for a while, I find that a lot of organizations are not measuring that. But they're feeling the pain. But when it comes to procurement, when it comes to purchasing, or trying to evaluate or onboard even open source solutions, if you don't have this data collected today, I take one thing from this entire presentation. It's start trying to quantify this. Because you might be surprised both by the impact that these things are having on your system, but if you do decide to solve this with tooling, with CapEx costs on the open source side, whatever it is, your life will be much easier if you're able to quantify the disruption and the cost of disruption within your organization. All that said, in this example, we assume a couple of things: 10 disruptions per year with 4 hours of average, or 4-hour average per disruption. And then 50 deployments per year. One of the big things about Kubernetes, again, going back to the triangle of control, is that when you have a deployment, it becomes so much more important for you to be able to validate that deployment to ensure that both your upstream and downstream dependencies are not going to be negatively impacted by your build. So monitoring deployments becomes the developer's job, or the SRE's job, DevOps' job in a lot of these environments. And it becomes critically important to prevent the type of outages that are more expensive. So when we put this all together, what does this look like? Around $3,500 per disruption, and $133,000 in annual cost just to validate those deployments. Now, if we look at this, it can get pretty expensive very quickly, especially the larger your organization is, the more you scale out. When we think about how observability contained this, you can reduce the cost by a factor of 5 or more. And this is something we've seen, with the folks that we've worked with, the folks that we've seen at conferences and webinars as we start to talk shop about observability and the benefits that it has. So if we're thinking about this, what does this number look like? Dramatically reduced, obviously by a factor of 5. But the other side of this coin is that we can't allow it to be a siloed solution. Holistic observability is important. We'll go ahead and talk through this within the context of our hidden costs here. So looking at this holistic observability, we think about context. And the context here is really important, both from a process and people perspective. So when you're thinking about context, it's not just technical context, but the context within your org to be able to say, as a service owner, I'm reliant on these services, X, Y, and Z, and these other services are reliant on me. Now, a lot of times that's harder to calculate, especially as we become more agile, we become more comfortable in Kubernetes. We might have teams that are spinning up services that may not directly impact me, but they might be calling a service that calls a service that calls me or my service. In that context is really important to try and maintain from a personnel perspective and a process perspective, but the complexity of the system means that you need a technical backbone for this. And that's where we think about this concept of context as a mechanism. And so looking through the communication context, in general, a lot of the observability approaches that you're going to be looking at use this kind of shared language. And that shared language is SLOs or SLIs. Again, thinking about the scenario where I have services upstream from me, maybe 3 or 4 layers upstream that are calling me, indirectly, it's really hard for me to know, hey, am I responsive in the way that I need to be for all of the various actors in the system that might be consuming or relying on me as an endpoint? And in that instance, the SLOs and the SLIs give us something that is kind of siloed to myself, but provides the context of how my slice of the world fits into our broader story. And it also helps us avoid alarm fatigue. So by focusing on data that is tied to those SLOs, those SLIs, my uptime indicators, my response time indicators, my error budgets, it's something that's very directly related to my scope of the world. And that shared context, the ability to rely on these KPIs, these metrics for SLOs, SLIs, obviously helps the team then save time and set goals. So if we set an SLI, and this is my advice to anyone here, if you're not sure, what do I set my SLO to? What do I set my SLI to? Just set it. You don't have to trigger alerts off of it immediately. You don't have to build processes off of it immediately. But in the absence of data, you're just going to be left wondering, what are we looking at here from a KPI perspective? So setting your SLOs, your SLIs, and measuring them, even if you have no idea where to start, is the best first place to go when you're trying to reduce the burden of operating Kubernetes in this world. The other side of context is the data context. So we've talked a lot about the personnel aspects. We've talked a lot about the cost savings that you can run into when you properly implement observability and kind of shift the way that you're thinking about your tooling and your systems into one where you can ask questions about that data. But if you think through that, the ability to ask questions about your data will run into the same problems as you would in just generally trying to root cause in a distributed system. You can't ask questions about your system if that system does not or that data does not have the context of all of your dependencies, both upstream and downstream. So in general, observability has to combine multiple data sources. We have to be able to look at effect and cause. Effect is really great to measure with metrics. You can have those metrics around application metrics, you can have those around business metrics, but in any sense, metrics help you understand the impact and the effect of a particular outage. But the more important side of this equation is the tracing, because that's what actually provides the context. And the example I like to use here is, imagine, we'll just use a really basic, like an API gateway. Maybe we have an API gateway in our system, and when I call that, the API gateway is just supposed to pass the request along to the downstream caller. But in a lot of organizations, ourselves included, we use fun names for our services. And those names aren't always indicative of what the services do. And if I have somebody who's less tenured, if I have somebody who's solely focused on a part of the world that's maybe 4 layers downstream from the API gateway, we can't count on those people, and we shouldn't count on those people to be able to go in and say, oh, well, when the API gateway has a response time of 500 milliseconds, that's actually because 485 of those milliseconds are spent on a downstream service doing blocking work. We can't rely on that tribal knowledge. The same way that we have difficulties in setting SLIs, we're going to have difficulties in communicating in a common language. And the trace data provides the system-wide, kind of that holistic observability context of what's happening in the system for any request at any time. So then, instead of looking at something and saying, oh yeah, the API gateway took 500 milliseconds to respond, we're shifting our way of thinking, and we're saying the API gateway did 5 milliseconds of blocking work. And then the rest of that work was being done elsewhere. So with that in mind, those two things, thinking about the tracing, the technical context that provides, as well as the context through the lens of our processes, our people processes, and measuring the impact that regressions, that outages, that difficulties can have on our stack, it's really important to focus on these things, because otherwise we're just going to be making guesses. We're going to be investing time in things that may or may not have an impact on the things that we're measuring or we want to be measuring, like system uptime and customer experience. So if you're thinking, if you're nodding your head, I can't see y'all's video. If you had it on, I don't know if this supports it from the other end. Probably not, but hopefully you're nodding along, or you're thinking this makes a small bit of sense. How do we implement observability? The biggest thing is to make sure that your services are observable. And this is kind of like a GNU recursive way of thinking. But in order to implement observability, you have to make sure that you're thinking while you're developing, while you're refactoring, what are the questions that I might be asking? And really importantly, the same way that setting your SLIs doesn't have to be a painful endeavor the first time you do it, neither does making your services observable. You will never be able to answer or foresee all of the questions that you're going to want to answer within your Kubernetes stack or within your applications. It's just, there's again, too many permutations. And so the recommendation that we give to folks who are starting along this journey is to just start with something. Start with your environment variables. Start with your connecting traces across context boundaries. Get to a state where you have something to bounce off of and something to iterate on. Because in absence of that, you're just going to be kind of swimming in the analysis paralysis zone of what are the possible questions I can have. Just start somewhere. And when you're thinking about making those services observable, it's really about the data that they emit and making sure that they have the context to be able to tie data types across service boundaries together. And obviously focus on your key SLIs. We want to make sure that SLOs are focused on your business goals. So uptime, response time, customer experience, it becomes very important in order to both maintain some semblance of control as a service owner, but also make sure that holistically across your stack, you have a common language to discuss performance indicators. And all of that requires you to put people at the center of that strategy. For us, we're very, very invested in OpenTelemetry, and we think everyone here could benefit by checking this out. OpenTelemetry is a standard for instrumenting your code, both from a metrics perspective and a tracing perspective. It is a project within and supported by the CNCF, just like Kubernetes. But the big thing here is that it provides a single set of APIs and SDKs to generate the traces and metrics from your services. And not only you as a service owner, but also the open source community, the infrastructure community. By developing a standard around this need, we're in a place now where we have libraries, frameworks adopting and instrumenting for OpenTelemetry, so that if you do leverage a piece of software like Istio, it's going to emit the same language of telemetry data that you can use to build your observability practice as the ones that you're going to emit within your services. And speaking that common language is one of the most important aspects of having a solid observability practice. Obviously, creating SLOs, if you're looking for a place to start, look at the golden signals: latency, throughput, and error rate. They're siloed. We can think about them within the context of any individual service, but the spike in those SLOs, the spike in those golden signals, will mean degraded performance for people around you. And so it's a great place to start. I really like this sentence here. It's less about thinking of the 5 nines and more, when people try to play a song, it plays. We need to start somewhere. And that's the big thing. I think with Kubernetes in general, it's such a widely scoped piece of infrastructure that it can be really intimidating to look and try and carve out where to start when you're looking at something like observability within the context of Kubernetes. And it's just about finding a common, sane place to start measuring, start iterating, and start building your practices. And then finally, just a little more context, focusing on people. We adopt these tools because they're supposed to make hard things easier. And that's not always the case. Again, the idea of auto-scaling Kubernetes based off of custom metrics. You would think, in theory, cool. But again, anybody who's tried that knows the complexity that's inherent to that process. So it's not always going to be easier. But observability can help you get a handle on the difficult aspects of Kubernetes and get you to a place where you might not think of yourselves as experts, but most experts don't. It's all about being able to ask and answer the right questions, and just getting to a state where you feel comfortable knowing how to interact with your system as an observer of that system. So if you're interested in all of that, if you're interested in seeing how Lightstep specifically fits into this story and helps enable faster deployment analysis, more cohesive understanding of your system at large, and the ability to ask and answer those questions, you can go check us out at lightstep.com/play. You can also always feel free to reach out to me. It has been my quarantine goal to not only grow my hair out, but try and get more active on Twitter. So feel free to tweet me at Parker for Work or parkerfromwork.com, at parkerfromwork, no.com. That'd be ridiculous. And with that, we'll move into Q&A.
That's terrific, Parker. Thank you very much for that. And we do have some questions under Q&A. So if you want to click on over to Q&A for new,
Sure.
First question from Kareem, if you want to hit that one.
Sure, absolutely. Slightly off topic, but any good recommendations for how to monitor API latency in Kubernetes, specifically the time the API call is taking from when it hits a load balancer, defined in Kubernetes, to when it leaves the load balancer? Now, this is obviously I'm going to have a bit of a biased response here, but I think the important thing to keep in mind here is the context required to answer that question in a meaningful way. So if we're thinking about the time when it hits the load balancer to when it leaves on the other side, you need the context to know, like, is this blocking or not? One of the exciting things about Kubernetes in general is that they are looking in at adopting and building open telemetry instrumentation into the platform. So a lot of these questions could be answered with native instrumentation. But the other thing is, within the context of a request, so imagine a request that actually goes through that load balancer, you can mark on those requests the time in which you're entering, leaving, or at the very least, looking at the edges. One of the difficult things in tracing or monitoring infrastructure that you might not own or be able to control is that you can't emit the data you might want from those environments. So the way that we like to think about it is in a well-controlled or well-understood networking environment. A lot of cloud environments fall under this. Is to look at the edges. So when did the call leave its last environment, hit the load balancer, and then when did the measurement start on the other side? And of course, that does leave room for networking latency to introduce itself, but in the scheme of things, that's usually negligible.
All right.
If you want to dig into this more, I would, again, Parker at lightstep.com or at Parker from Work on Twitter. I see another question here from Daniel. Is Jaeger open tracing platform close to Lightstep? That's a great question. So the kind of thing, the one area where we overlap with Lightstep and Jaeger is that we use tracing data as our foundation. The delta or the difference there is that Jaeger is really focused, as well as Zipkin, another great tracing project in the open source space, is that they're both kind of focused on understanding the performance of individual requests. And Lightstep, we actually built our platform in the same vein, but the big difference is that we're built for scale. So unsampled trace collection at whatever scale you operate, we collect 100% of the requests. But we're trying, as we continue to build our platform, to build abstractions on top of that trace data. So getting to a point where you don't need to open up a single trace to understand performance. We're very focused on the aggregate analysis that you can derive from trace data and the context that that trace data provides. And then on the other side, the ability to build opinionated workflows on top of those aggregations. So go check out our sandbox. It'll do a much more eloquent job of explaining that than I am. But the big thing is, if we wanted to be able to understand where's a bottleneck, instead of opening up a trace, we built our platform to just be able to build metrics off the trace data, click on a spike that you see, and then we show you only the relevant data within thousands of traces at once. And then let's see. Should microservices be designed as microliths or macroservices to balance complexity and operations management? Microliths, macros, I love both of those. There's a movie a movie quote, about dealing with absolutes that I think is probably pretty relevant here. But in general, my philosophy, the philosophy of the folks that I respect in this space, is that you should think about your needs. You shouldn't be adopting microservices because they're flashy or because you really want to get an introduction into Kubernetes. You should be adopting them for the organizational benefits. In the same way, I would think about the design of microliths or macro services. There is a benefit from both sides, from a complexity and an OpEx and an operational management perspective. But I think the bigger thing here is just, if you have an organizational need for one or the other, then invest in that approach and figure out how to solve the problems that come up. It's always going to be a balancing act, but that's what Excel's made for. You can go in and balance the pros and cons and come out with a number or an approach that works for you. Cool. Oh, sorry, I just had a bunch disappear. Patrick, I might rely on you here. Anything else? I saw a couple disappear.
Yeah. There's from Sareem, is kube cost model good for cost management? And then you have one from Jeff Duck as well after that one.
Oh, cool. Now I'll be super candid here. I'm not familiar with kube cost. I did just give them a Google here on my iPad in front of me. And in general, I'm very much behind any tooling that kind of helps you reduce your spend in this world. I think, especially in Kubernetes, it gets really easy to spin up resourcing or to have resources or services sitting out there in your architecture that nobody really knows about, or that are not providing value inherent to the cost that it's bringing to your company. So I'll check this out. Again, something I have not looked into. I certainly wouldn't want to endorse it in this method, but you've given me something to look at, and I appreciate that.
It looks like Jeff has a comment.
Sure. Let me pull over to chat.
No, it's in Q&A. You're not seeing the one from Jeff?
Oh,
in Q&A.
Yes. Sorry. When I heard comment, I was thinking.
Yeah.
Cool. We use an API gateway to aggregate data from many microservices to make microliths. Interesting. I'm trying to, so the aggregation, I guess that seems kind of abstract. I don't necessarily have a comment there, but Jeff, would love to hear more about this. The microlith terminology in general is one I'm not as familiar with, not one that I've heard from the folks I work with or the customer base. So I'm very interested. Sorry, I don't have a more interesting response to that, but it seems very abstract in an intelligent way. If you want to dig in more, please feel free to find me on Twitter or by email.
The one other question that we had was from a different channel that I then entered in. Parker is it's under my name there. What are your thoughts about Rancher and OpenShift for what these platforms provide? What does Lightstep duplicate or add to those environments?
Yeah, absolutely. In general, they're kind of separate goals, right? So Lightstep is really built towards solving the observability problem. And that observability problem, again, thinking about the OpEx costs of trying to dissect that data and make sense of it quickly, and then the CapEx costs of running that at scale, especially if you wanted to kind of get the same value and ability to capture edge cases and anomalous transactions as Lightstep to sample it 100% or analyze 100% of your data. The CapEx costs there and the OpEx costs are going to be crazy. Just for context, for some of our larger customers, we collect on the scale of over a petabyte of data a day, and every one of those requests is analyzed. And so to build that, it'd be pretty crazy. And so thinking about Lightstep, we're really built to make that cost significantly less. So taking the data, giving you the ability to create good data, to ask questions of that data quickly. Whereas Rancher and OpenShift, we're seeing more and more these platforms that are kind of more focused on the infrastructural management side of Kubernetes. They are adding support for things like tracing at the app layer using the OpenTelemetry or OpenTracing, OpenCensus technologies, but they're not really geared in the same way. It equate it to like AWS has or GCP has EKS or GKE, but they also have X-Ray or Stackdriver, but those are not tools that you can grow into. Those are tools that you pretty quickly grow out of. And so while you have like Rancher and OpenShift that might toe into that space, they're really focused, and their value add comes from the management side of the infrastructure, not as much the observability side of the app layer. Cool. And I saw, Jeff, you can reduce chattiness to your microservices by making less API calls, but still have the microservices on the back end. That makes a ton of sense. Again, feel free to reach out. I'm always up, especially right now, to having my perspective broadened. So feel free to reach out if you have any more questions, if you want to chat Kubernetes or anything else. Really, I'm around.
So Parker, did you want to reiterate your email address and the Twitter handle just so we can make sure everybody's got that?
Absolutely. My email is, I'm just going back through the slide navigator here. My email is parker@lightstep.com. My Twitter handle, which it's dumb, but I'm very proud of, is Parker from work, because I'm Parker from work.
Very descriptive and specific. That's awesome. So Parker, thank you very much for your time today. And before we finish overall, I'd like to thank you as well as Lightstep for your sponsorship of today's online learning session. It seems like we've had a lot of good questions that have come out of it. And we just want to remind all of our attendees that the recording of this session will be available in 24 to 48 hours. You'll be receiving an email from Big Marker as well as Dev Network telling you that availability, so you can take a look at it. You can then be able to forward that on to your coworkers as well, and you'll be able to review the video as well as the chat and also additional information. And as a reminder, just contact Parker if you do have some direct questions on his email address as well as Twitter handle. And finally, the recording itself is part of our archive at devnetwork.com. We have a slew of webinars and resources for dev professionals. We're going to be adding this particular webinar to that this great webinar to that list of webinars. And so check that out at devnetwork.com. And I just want to thank everybody for participating, and have a great and safe day.
Thanks, Patrick. Thanks, y'all.
Bye-bye.